Hands up, hands up, hands up. Let's go ahead and get started on our math minute, our last one for the week. This is math minute 59. Whew, we made it. It's the end of the week. And I do have a public service announcement at the end of the video, so make sure you stick around to the end so you can hear my public service announcement for this Friday. We're on math minute 59. We are ready to go. I got it up. Let's push it down and make sure that you got your tool in your hand. Get ready to go. Whew, I can get 5. Yes. Number one says, write 98% as a decimal. Whoa, where'd all my markers go? I need to stop throwing them around. Let's go ahead for the first time this week. I think it's the first time this week. Let's go for green. So let us go ahead and figure out what's most important in that problem. So the first thing they said, they want you to do something with 98%, and they want you to do something and make it a decimal. So if you are going to make 98% a decimal, what do I got to do? To make to make a decimal a percent, you got to times it by 100. So if you're going to have a decimal and you're going to make it into a percent, you got to times. If you have a percent and you're going to make it into a decimal, you got to divide. So we're going to take 98 and we're going to divide that. If we had to times it by 100, then we have to divide that by 100. So if we divide that, whoa, I forgot to hit divide by 100. And the answer from PhotoMath is 0.98. That wasn't bad. That was a good start. That was a pretty easy problem. We've done a lot of the percentages and the fractions and the decimals. We've done a whole big bunch of them. So we should have some semblance of idea of what we're doing. It looks like number 2, we're doing something very similar. So circle the greater value. Ooh, bigger. You want to pull out the monster? I think we should pull out the monster. So let's get rid of this and we'll just go ahead and we'll just pull out the monster instead. So which one's going to be bigger? We have 65% or we have 7/10. Which one is the monster going to eat? Well, both of them are not decimals, and we work with decimals. Always try to convert it to decimals. So we have a percentage. If we divide that by 100, we get the decimal. So let's do that. Let's get this one done first. We'll just do one at a time. Take our time. It's Corona time. And for an adult, that makes a lot more sense. So we have 65. We have to divide that percentage by 100, and that will give us our decimal. So our decimal in this problem is 0.65. How did I get that? I took this number, I put 65 divided by 100, and that will give me 0.65. Now, how do I get rid of the fraction and make that a decimal? That one's super, super easy too. So, all right, think about it in your head. What did we do the last couple of times? All we did was we took the parts, divided it by the whole. Because remember, if I read it, 7/10 is also 7 divided by 10. Or 7 divided by 10. And if I put it on my PhotoMath, which you should have your tool, put it in your hand, make sure it stays in your hand, because it's not like you're doing any writing right now, so make sure you put your tool in your hand. We do 7 divided by 10, and this one becomes 0.7. Well, now we got to figure out which one is bigger. How do we figure out which one is bigger? We line them up, right? Line them up. So we line up our decimals. Now we'll put the 0 there to make sure everybody is understanding. So we have zeros done, decimals are lined up. 7 or 6. So which one's bigger? 7 or 6? 7. If I was going to have, let's say, we used cookies before. Let's go with cupcakes, because I had that cupcake today for Morgan's birthday. So if I had an option to have 7 cupcakes or 6 cupcakes, I want 7 because 7's bigger. So this number here is bigger. So which one are we going to eat? 65% or 7/10? We're going to eat 7/10. There you go. Ready to go. So you want to eat 7/10. Down here in number 3, again, they want to trick you. They picked this one on this paper because what they want to do is they want to say, oh, you don't need a calculator. But for right now, we do want to use a calculator. We want to make sure that we do it both ways for everybody in our classroom, not just for some. So we have 5.234 times 10. Now, the answer on photomath in our calculators is 52.34. Yeah, that sounds about right. So let's go back to what we were discussing yesterday. What we were discussing yesterday is anytime you're timesing or dividing by 10 or 100 or 1,000, just ones and zeros. If it's just one starting the number and zeros after it, you can do this trick. What they're asking you to do is that let's go ahead and put this number down here. Whoops. So we have that number down there, and they say that how many times are we going to move it in which direction? First off, I look at the times, right? So if it is times, I'm moving the decimal point this way. So this little time sign right here says I'm going to move it that way, first and foremost. So it's going to start here. How many zeros do I have? I only have 1 0. Since I only have the 1 0, I only move the decimal point one place, which makes it right there. And so if I rewrite my answer, does it matter if I used my brain and used some tricks, or did I use the calculator? No, it doesn't matter. Because as long as you have a system that works and the calculations make sense, go for it. That made sense both ways. Nice job for us. Now we're going to round numbers. Oh, rounding numbers. Rounding numbers is so ridiculous. So ridiculous. They try to make things way too difficult for their own good. So what we're going to do is that we are going to, I'm not going to pull it up on a Google search, but everyone in my class knows how to use the fractions calculator and also the rounding calculator. So using the rounding calculator is an option. It's a little dark in here, so it'll be more difficult for me to do that. So we're going to go ahead. They want us to the nearest tenth. So you go to the decimal point, put your finger on the decimal point, and you go tenths, hundreds, thousands. So that's 6. We ain't worried about the 6. We're a little bit worried about the 4, but the 5 is the one. It's either 5 is going to stay the same or it's going to go up because we're rounding to the nearest tenth, and the 5 is in the tenths position. So what we're going to do is we're going to look at the number next to it. If it is 5 or higher, we're going to go up. If it's not 5 or higher, it's going to stay the same. So on our answer, no matter what happens, it's going to be 8 point something. You might not be able to see it from over there, so I'll put it down here. 8 point something. If I look at 5, I go next to it is a 4. So, ready? 1, 2, 3, 4. Did I hit 5 yet? No. Since I did not hit 5, it stays the same. So over here, all you got to do is go 8.5. Round to the nearest tenth. It doesn't seem hard, but the problem is you're combining place value with, you have to not just know the place value of what you're trying to do, but the place value of the one next to it. And it does get complex. So if you really do need to use the tool online, don't feel bad. Just use the tool online. In fact, I just got a message from Angel. I just took care of it while I was uploading my last video. And Angel wrote that he was concerned that when he was doing his Achieve 3000 English articles, that if he was watching the articles, the videos that I made for you, that it was cheating while he was doing the activity, and it's not. Because remember, it's not about getting the right answer. It's about you understanding what the question is trying to ask you and making sure that you yourself, that you understand the material. It's not about right answers. Get that stuff out of your head, out of it. So Angel, Much love, man. You literally, you message me and you comment on all the videos, and I know how hard you're working. So please don't worry about it. I don't know why, I'm almost losing my voice tonight. It's still not coronavirus, guys. I still think it's allergy season. Number 5, 2 cubed. That's a new word for us, right? Cubed is a new word. When you see a 2 up there, it's called squared. If you see a 3 that's an exponent, it's called cubed. But it's still the same concept. This is our base, so you write down the base. So I'm gonna put it up a little bit so I give myself more room down here. How many times are you gonna write the base number? 3 times. Because, hold on, I'll put it bigger up here so you can see it. I'm gonna write it 3 times. And what do I do in between? What function do I use with exponents? You could do it. We've been doing it all week. You could do it. You could do it. I got faith. What are we gonna do? We're gonna do adding, subtracting, multiplying, or dividing. I'm gonna multiply. In between those, we're gonna multiply 2 3 times. So get your calculators out. 2 times 2 times 2. So 2 cubed is 8. Beautiful. Stunning. That was good work. Look at that. We even squeezed the monster in there. It's beautiful. So what I'm gonna do is I'm gonna fold this backwards because that will give me a little bit more paper, and it's going to stop giving me a stroke when I'm trying to get things done here. All right. We're almost to the service announcement, because there is that public service announcement I'm going to be doing at the end of this video. I love tape. Tape has so many uses. Let's pull our 6 through 10 down. Can I get them all? Nope. But that last one up, that first one up top and then the last one at the bottom, it's real short, so we'll be okay. 10 pie. They brought back the pie. I had cake today, so maybe I'll have pie tomorrow. I don't know. I'll have to figure that part out. But I did figure out something amazing. I had an epiphany. I'm going to take a break for a second. I had an epiphany because there are what's called carrot cake donuts. Hold on. Let me grab them real quick. And they're from Hostess. They are short term. They're carrot cake. I don't know. I'm going to probably mess up the focus on it. But they're amazing. They're so good. And I do not need these, but I do 5 miles a day, so I could have 3 donuts. But they're so good. If you get a chance, and I'm not getting money for that either. Even though I'm on YouTube now, I'm not getting a sponsorship from Hostess. But those donuts are amazing. Up here. So we'll go back to the pie. What happened to my pen? There it is. It's just dark in here. Now it's like super dark because now it's even later. We have 10 pie for people that I might have messed with the actual focus of the camera. It's 10 and it's stuck to pi. If things are stuck together, what function is that? It's not adding, it's not subtracting, it's multiplication. It's not division, it's multiplication. So what it's really telling you is that the problem really looks like this. 10 times pi. Now, who can remember pi? You can remember it. 3, say it, 3.14. Say it with me. 3.14, 3.14, 3.14. I would keep going, but I know there's at least 3 kids right now going like this. Oh, Chir, stop. Please, God, stop. I'm stopping. I get excited about pi. So we're going to get rid of the symbol, and instead, we're going to put 3.14. We also don't need the calculator on this one either because we can move the decimal point, just like we talked about before. But we'll do the photo math way first, then we'll go ahead and do it the Corona way. So I have 10 times 3.14. 31.4. They just moved the decimal point. Just like we talked about up front. If it is a 1 at the beginning with zeros afterwards, and it's a times problem, you're moving the decimal point. If it's times, you're moving it that way. And you just count at the zeros. If it's division by 10, 100, 1,000, a million, whatever, then it's going to go, the decimal point is going to go this way. So this way is times, this way is divide. Did I do it right this first time for once? Yes, I did. So, all right, how many zeros we have? We have 1 0. Since we have 1 0, we're going to move our decimal point. Remember, that way, it's times, so it's going that way. We're going to go, boom, to the right, and then the number becomes 31.4. So we were right both ways. We were not just right, we were super right. So let's try to move this up just a little bit, because I'm gonna try to get, no, I'm not gonna get it. Because I wrote a little bit too much right there. I shouldn't have wrote so much. We got the same problem, just like we did yesterday. We gotta figure out what relationship these two bottom numbers have. Because we can do it the photomath way. So go ahead and we'll put it in our photomath calculators. We have a fraction of 6 over 18. And then we put the equal sign. And this is a question mark. Can I put a question mark in photomath? No, I can't. Since I can't put a question mark in photomath, I have to put a letter. So that letter for me is going to be D. I like D. So, and then the bottom number is going to be 6. So photomath told me that this area right here, the value is 2. So the question mark is 2. So it just told me. No questions asked. Just make sure. Yeah. So what I'm going to do is that I wanted to see how they explained it. I explain it better. You want to see the relationship with what these two numbers have. So what do those two numbers have in common? You're going to be simplifying, right? So which magic number are we using? 2, 3, or 5? We are not going to be able to use the 5. Neither one of these are counting by 5s. You can't times anything, get that by 5, so 5s are out. 2s, we could do 2s. We really could. 2s would work within reason. 2s would work within reason. Here's the issue with the 3. Is that the 3 can't work on this. Or can it? Which one would work the best? Let's put it on our calculators. We know that the 2 and the 3 would work with the 6. It would both of them. We could reduce either one, so it's fine. So that's, we don't have to worry about that particular problem. But we do have to worry about the bottom. So let's try that. Let's try 18 divided by 2, which is 9. So we could. So we can do this as 9. So okay, we got that part. Got it. But what if we did 3? Oh, it's a 6. So that's even smaller. So we always want to use the biggest of the magic numbers. So because 3s work and 2s work, we want to use the 3s. Okay. So what is 6 divided by 3? No, I don't want to waste. Yes, I do. I want to waste paper. So if we're going to do this longhand, so 3. How many in each one? 1, 2, 3, 4, 5, 6. That's literally division. When you look what I did just now, that simple, wonderful graphic representation is division. If someone has not shown you that in the past, I want to kick them too. I gotta like suppress my violent outbursts. It's crazy. So here's my division. So what's my answer? 2. So the top over here is gonna be 2. But now we gotta check to make sure this is right, because we know this is right. So let's check it out. So 18 divided by 3 equals 6. Correct. So we're all set. We have achieved beyond all human ability. We've gone through the whole thing and it was epic. So the answer to your question, the answer to your whole thing, just to make sure we are on the same page, is that. Because we reduced that by 3. And since we reduced it by 3, we could figure that out. Let's take it up just a little bit. Yeah, there we go. I'm gonna get there. I'm gonna get there because this right here is not going to need that much. I am not going to write that much. I'm going to suppress my teaching urges. Suppress. 36 eggs are equal to how many dozens? No, I want to write. I want to write so bad. Okay, all right. So the first thing we need to know is how many eggs are there? So we have 36. So we have a total of 36 eggs. They're going to equal how many dozen? So how many are in a dozen? Alexa, what is the number in a dozen?
This might answer your question. Dozen is equal to 12.
12. Okay, so we know that another word for a dozen is 12. What am I going to do with that 36? What am I going to do to that 36? Well, think about what that's called foreshadowing, children. I saw this problem and I foreshadowed how to do the answer. Foreshadowed it. It was amazing. We're going to divide because we're going to take those 36 eggs and we're going to put them in groups of 12. Since we're going to divide 36 eggs into groups of 12, we're going to do 36. We're going to divide that into groups of 12. And it's going to tell me how many dozen that is. Drop the mic. Ooh, I think I just wrote on my counter. That's okay, it's dry erase marker. Drop the mic, people, drop the mic. Do you see how that just worked itself out right there? So we're going to take our calculator. Let's do the calculation together. 36 divided by 12 is 3. That leaves us 3 dozen eggs. That was so satisfying. And look, I even contained it to that little bit of paper right there. I did a good job. I could have done more. I wanted to do some more, but I'm trying to be better. I'm trying to, what is that? Edit. Editing is good. Oh, number 9. I hate these problems. I hate them. I absolutely hate them. I am an exact type of person. If you've watched some of my other videos, I know I come across as a very laid back, chill type of person, but I also am a robotics instructor. I'm the robotics coach for my team at school. And estimating is an okay skill, but it's really not as important as being like exact. Because when you're doing like programming or you're doing like you're building something, you can't be off by a little bit. You have to be correct on those types of things, because if not, the project doesn't work. So I'm going to need your moral support. So I want you to send it through the screen, because it worries me. It worries me sometimes about how to estimate, because I myself like to just do the problem. I wish I could just like scratch out that word and just do the problem, be done with it, but I'm gonna be a good girl and I'm gonna take care of business for you guys. The best way to estimate an answer is to get rid of the decimals. If you have an 8 here and you have 4 or less, just like rounding, well, you can get rid of. So is this 4 or less? Let's count. I'm sorry, 5 or less. 1, 2, oh, did I get to 5? No. So we could just drop this and leave this as an 8. Oh, that made me twitch trying to do that. All right, so this 4 right here, we try to get rid of that decimal. Let's see if this is 5 or higher. So here's my 5. 1, 2, 3, and remember we're looking for 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it above 5? Yeah. If it's above 5, we can't just drop this out and not do anything to the 4. We have to make the 4 into a 5. So now we're estimating. So we've kind of just said, we're not worried about that. We rounded that down. We said, we ain't worried about that. We rounded that up. So now it's 8 plus 5. So can you tell me what 8 plus 5 is? I know photo math can. 8 plus 5 is 13. So just so you guys can see it over here, 8 plus 5 equals 13. That was estimation. Thank you for the moral support. I felt it. I felt it through the screen. I felt you here with me, children. I felt you here. Thank you very much. I appreciate it. Going down to the last problem. Ooh, I did get that in. Good for me. All right, if you can't see that over there, because I'm not sure my camera can get that shape over there, I'm going to draw it here. And don't make fun of my drawings. So it's a circle, and it's cut up into... And I love building some fractions. I do. I totally love building fractions. I just adore it. So, and then they want you to color in this one and this one. So even if you guys can't see it, this is representation, you're fine. I'm gonna read this. What fraction does the shaded portion of the circle represent? We're gonna do both. We're gonna do both the shaded and the unshaded, just so you can see. If the shaded, how many shaded? Because remember, a fraction, you put the part you're looking for on top over the whole. So how many parts are shaded? 1, 2. And I'm going to change colors real quick so you guys can see. So the shaded portion is 1, 2. So 2 goes on top. Parts go on top that you're looking for. They could have said the other one, so we'll do that in a second. And then how many for the whole? Oh, I managed to do that whole thing without having to throw my cap away because I didn't fidget. Good for me. So we got to do now the whole. So we have 1, 2, 3, 4, 5, 6, 7, 8. Now, did you see there that I put those little numbers in every portion, even the shaded ones, because you're trying to figure out what the whole of the how many pieces are all together. I kept trying to say whole over and over again, but that's not helping the situation. So we know that there are 8. So our fraction becomes 2 over 8. So that's the fraction. This is what they're telling you. They want the fraction of the shaded portion represent. So we got that. Boop, 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 boop. Boop, boop, boop. So 2/8 are shaded. Now as a bonus, what's not shaded? So let's go for it and let's try to do the non-shaded. Non-shaded, 1, 2, 3, 4, 5, 6. There are 6 pieces of the shape that's not shaded. Now, does that change the bottom number? That's why I wanted to do both, so you guys can see that. That does not change the bottom number because this shape did not change. The only thing that changed what we were trying to look for inside the shape. It stayed an 8. And is this number reduced? Is that fraction reduced? What do you think? Can we use one of the magic numbers? What's our magic numbers? I want to hear them. Say them out loud. So, because if you say them out loud, you're more likely to remember them. 2, 3, and 5. Are both of those numbers even? Yeah, so 3s are out. Can I divide either one of those numbers by 5s? That's out. So we can do something with the 2s. So what is 2 divided by 2? So we got to divide both. I'm running out of room. All right, so down here, 2/8. So I divide by 2. If I divide the top by 2, I got to divide the bottom by 2. So how many? So what does my fraction reduce to? 2 divided by 2. 2 divided by, a number divided by itself is always 1. And what is 8 divided by 2? 4. Do the calculations with me. So what they're really telling you is that 1/4 of this is shaded. Here's where, no, we'll go into that next week. I'm not doing it because I think I've run over on this video already by massive amounts. So no. Over here, can I do the same thing? Well, we already know 3 and 5 doesn't work for this bottom number, so it's definitely not going to work for this one. So what am I going to divide this number by? 2. So on this side of the fraction, we have 6 divided by 2. Whoa, killed that number. 6 divided by 2 is 3. So I'll put the answers here. And 8 divided by 2, we already know, is 4. If I add those two fractions together, if I add 3/4 and 1/4 together, what do I get? 1. And once we get a little bit more knowledge about this stuff down, you guys are going to be rock stars at this. So don't worry if you didn't get all of that right now. I'm just exposing you to it until we can get through the whole thing. Don't stress. Now, my public service announcement, because like I said, I really did run over already on this video because I can't shut up. This will be the last video before spring break. Now, I had told your parents that we were going to continue working through spring break, but the school district asked us nicely not to work through spring break and to give you guys the days off. So I'm a good little soldier, and I'm going to post one more video on Friday to give you some ideas for things you could be doing next week, just enrichment stuff to keep you busy and keep you learning. But there will be no playlist for you guys to go through. And I'm not expecting you to do CNN 10 next week. So I want you to do CNN 10. The rest, I want you to do CNN 10 until Friday of this week. Friday. Friday is the last one until we get back from spring break. And don't worry, I'll post a video that day, and I'll make sure to text your parents to let you know that you're back into class. But you're gonna be all right. Everything's gonna be fine. We're doing good. And I do appreciate all the effort. Because I was very serious, like I told you a couple nights ago, is that when I got to sit in a meeting and a lot of the other teachers were having problems with getting their kids working, and my kids are texting me for the passwords, and I could see that people are doing their videos at like 9 and 10 o'clock at night, I could tell that there's a lot of effort going on, and I'm extremely proud of you. So enjoy your week off, enjoy your spring break, but this will be the last math video, and I'm gonna have 1 week hiatus. We'll be on vacation for 1 week. As soon as we have that 1 week off, don't think you done, because you are definitely not done. We got lots more to learn, and you better thank the school district, because the school district is the one that told me I cannot give you any more work until the spring break is over. So thank you guys very much. I hope you have a wonderful break. And if you are religious or you celebrate the holiday, I wish you a very happy holiday. Stay safe, stay healthy.